Peter Cutsey, Part 2, raw data. We're on vectors 0, 1, 5 degrees to intercept the 102 radial of the Kabul VOR for the VOR DME runway 29 as we briefed in Part 1. A little bit on this approach. It's a very different approach. Our position is such now that we are 23 miles from Maybe. So we're somewhere off the chart. We'll come into the chart later. Just to let you know of our position. The minimum is based on climb gradients for your aircraft weight, temperature, etc., computed by your flight dispatch. We'll say for today's reference, we are good for a gradient of 290 feet per nautical mile to 18,000. Therefore, we can use a minimum of 8480. As most airlines SOPs dictate, we will add 50 feet to that. So, which brings our minimum to 8530. 8530 set. All right. So on the MCP later, because we'll be doing this procedure in an LNAV, VNAV mode, when we're ready to configure for our final descent, we will set the minimum on the MCP rounded to, of course, 8530 rounded up will be 8600. Okay, so we've got that organized. Let's get back to what we were talking about in Part 1. Right now, here we are at 1000, flaps 5 speed. Remember, the nav display is computed data. We'll go across to the first officer's side, and we've set the VOR center as we discussed in Part 1. So we can actually follow through to ensure that the map that the captain will be flying, he's the pilot flying. For today's flight, the first officer is the pilot monitoring. Some companies, and I totally would highly recommend it, that the pilot monitoring in this circumstance be in raw data to follow through on what's happening. So let's go back to the captain's side. And so that's just a little bit on the briefing. I'm going to cut us loose now and give us an intercept heading, approximately 45 degrees off of that radial, and we'll follow what happens on the map back and forth with raw data. We were given a heading of 325 degrees to intercept and fly the 102 radial inbound. At this point, would go up and arm LNAV, and the FMC is giving us a message here that not on an intercept heading. Well, we are on an intercept heading. It could be because of our distances so far. So let's just see, or it could be a problem with the software in this computer. In any case, because of the distance, we could go to a VOR lock and allow the autopilot to intercept the radio, and we'll see what discrepancies we get. So we'll go back to the raw data and see what kind of response we get. We're pretty far from the field. We are actually 43 miles from the field, and that could be the reason why. In any case, this particular demonstration and me talking through what's happening is what you would really be doing in the real world. We are in VNAV vertical mode, Pat, when we have Vorlock engaged. So Vorlock has been engaged, and we'll see how we close on the radial as we're moving. Here, the distance is quite far from the field, and that's probably the reason why we didn't get an LNAV armed. So we'll watch it closely, and we're moving. We're at 17 miles from Maybe. We'll come on to the map here soon and have a look at it. So let's just watch what's happening here with respect to our intercept. Now, we're in a simulator. It's a very realistic simulator, incidentally, but it probably is giving us what could happen at this distance from the VOR site. It, because of the terrain, because of our altitude, and because of the mountainous terrain between us and the VOR, we could be in an area of poor reception. So if we were wanting to get right onto that radial, we'd have to fly the radial manually. So let's go up and use the autopilot in a heading mode. So we'll make sure our heading is what we would like. First, select heading, and we're now no longer in a Vorlock mode. We're in a heading mode to intercept the actual radial. So we have to remember that. So let's just have a look over on the first officer's side again of how we are closing on the radial. We need a little bigger cut. So let's advise ATC. We'd like a little bigger cut at that radial. And then when we are ready, we'll try LNAV again and see, we're close enough now to get an LNAV, and we did. So that's the importance that I'm making. Everything that we're doing here could very well happen in real flight. I didn't plan this, but because of distance, terrain, and reception, you could very well have that happen. Now we have captured, if you notice on the FMA, LNAV, so we will align our heading bug with our course. So looking good, looking good. Maybe 11,000 or above, we're at 11,000, and we could set the next altitude after 11,000 is 10,800. So it's really only a 200-foot difference. So you have to be very careful here before you configure for final descent. Let's just freeze the simulator, and let's have a look at our nav display. And with this company, they've got vertical situation display, which is really an incredible piece of equipment. So maybe 11,000 or above, chemo 10,800 or above, that is reflected on the chart as that, and that is correct. All right, now let's go over to the first officer side and have a boo. Okay, we're on the radio. Now let's go up and that's VOR center. Let's have a look at the, come out of the center mode and come down and look at the expanded mode. There's VOR expanded, all right? And we are on the 282 radio, or 102 radio, which is 282 inbound, and our heading is 285. So this is part of what we were talking about in part one. Now, just for demo purposes, let's go to approach and see what the approach would look like. That's the ILS, which is tuned and because the ILS is lined up with the runway, which is 284, and we are on the VOR on the 102 radio, that's the reason for the discrepancy. But that's what the other mode, the approach mode, would look like. And if we were flying an ILS, we're not, and we use the center mode, there it is in center mode. So from what we are looking at today on this flight, with respect to the ILS, which is the 104 track or 284 track inbound to the field, and we are actually navigating to the VOR on the 102 radio. That's the reason for this discrepancy. This is for demonstration only. All right. Now we can go back to VOR, as you can see, and there we are. So everything is the way we want it. The first officer's confirms the raw data on the first officer side, confirms that the captain's map is correct. All right. I hope you enjoyed this briefing on raw data. It's most important that we as pilots understand that the icing on the cake is not necessarily correct all the time. Thank you for watching. See you in my next video.